Hello, Professor. It's great to see you again here in lab.
Hello, Jovish. It's nice to see you too.
Today I came with my friend Jonathan. He is in charge of the 3D printing process.
Hello, Jonathan. Nice to meet you.
Hi, nice meeting you too.
I explained him last week. You explained the design of the prototypes and how to do the experiments and the graphical analysis and statistical analysis.
Excellent.
So now it remains to get the final conclusions, the optimal settings. So today, could you please explain us how to get the optimal settings from the analysis you have made in the last weeks?
Yes, sure. We can go through the response optimizer and identify the optimal settings for the this 3D printing process. We have three variables like layer height, print speed, and infill density. So we saw which of these really affect or not your three responses. But with that analysis, so we just got an insight of the things that really affect or not your response, but we really didn't know what are the values that will help you minimize or maximize this response. So in Minitab, it has a tool called Response Optimizer. So this Response Optimizer will help us identify the values of your settings to minimize these responses. So let's go to Minitab and see what are the results and any questions that you can have, so we can discuss it.
Perfect.
So here I have Minitab with all the data from your experiment, all the inputs and all the outputs. Then we did the analysis that Jovish already showed you. So to find this optimal setting, so we need to go back to DOE, then factorial, and here we will go all the way down. So here we have the response optimizer. So this response optimizer is like some sort of optimization method that will help identify the optimal settings. So here it already identified the three responses that we have been analyzing. So we can do the three at the same time or do one by one. So I will show you how to do it with one. So we have here strength. So strength, we want to maximize, and let's put response surface not optimized and print time not optimized. So in this case, we'll only consider the strength, and then it will give the settings. If we go to setup, in the setup, we basically just have the lower and the upper value. These are calculated from the experimental data. And since we want to maximize, so it gets, your target is like the maximum that we know so far from, the experiment. Then if you go to options, in options, we can specify any type of constraint for the variable. So imagine that now we have layer height from 0.1 to 0.3 millimeters, but maybe you want to constrain that to a different region, maybe just, 0.1 to 0.2. And you can do it for all of the other variables, or it could be that you just, for one of the three variables, you want to hold it to a particular value. Maybe you want, 0.15 to be the layer height, so it will fix this value, and the others, it will consider the range that we already have. So I will just go back to non-constraint, and here we can specify some star value, like when we're doing an optimization, so we can put a value where it will start looking for the solution, but we can just leave it empty. In the other ones, we don't need to modify anything. In the view model, you can see the model that is considering for this optimization. So with the previous step, when we were doing the analysis, Minitab create a regression model, including all the interactions. So now that regression model is the response for our optimization algorithm. So I will just click now. Okay, so basically you just need to select the response that you want to optimize, and if you want to maximize or minimize. So Jonathan, here we have the results after we run the optimizer. So in the first table, it's for strength. So we specify to maximize strength. So what it's telling us is that we need to use an layer height of 0.1 millimeters, print speed of 40 millimeters per second, and infill density of 50. So if you operate your process using those settings, your strength is maximized, and the expected strength for the prototypes is 86 megapascal. So that's what you will expect by using those settings.
Okay, so it means that if I am interested in the roughness, I will look at the next table and I will look
Yes.
at a layer height of 0.3 with a print speed of 40, and then I will get the results on this table.
Yes, yeah, so an infill density of 20, and the expected surface roughness is 22 microns. Similarly, if you are interested in print time, so you have the condition that will minimize print time. However, if you take a close look, these solutions are different. So the settings are different. So for the first one is 0.1, 40, and 50. And for the last one is 0.1, 80, and 20. So the settings are different. So what it means, and it's different for the three cases. So what it means that we cannot find a unique solution that will optimize the three responses. So you will need to decide, maybe which one is more important for you, or we can pick one of these three, or we can try to get like a combination.
So this means I'm not able to solve everything together in this way.
Yeah, so the same settings, so like a set of settings won't give you the optimal solution for the three of them. So we will need to make some sort of compromise and decide which one is more important. So we will go back to Minitab, then we can discuss, some sort of priorities and get a solution. But I make a plot for you to, show this thing that, we cannot get like a unique solution to optimize the three objectives. So here, what we have is the 24 runs of the experiment. Each of these points is one of the prototypes that you produce, and we have in the x-axis surface roughness and in the y print time. Both of them we wanted to minimize. So you can see here in the blue, so these are the solutions that give you the lower print time, but not the lower surface roughness. So you can see that, they are actually more like, bigger values. And, here we have some of the settings that give you the lowest or the smallest surface roughness, but it's not, the best print time. It's more like in the middle. So ideally, we will want to have like a solution around here. So that will give you a smallest surface roughness and a smallest print time. Unfortunately, we don't have those type of settings because, like this compromise between the two. If you remember when we were doing the plots, for example, to minimize print time, so you need to print faster. So you increase the print speed. But if you increase the print speed, then the surface roughness gets higher. When you print slowly, so the printing is, nicer, more smooth. So then, there is this type of compromise.
That's exactly what we see in experiments.
Yes. Yeah, so then, we don't have like a unique solution. So let's go back to Minitab and let me show you how you can get now just one solution because, you have these three and then you will say, okay, which one should I use? So let's go back here. I will go back to the response optimizer, sorry. So we go back DOE, factorial, response optimizer, and now here we can select to optimize the tree at the same time. So we have a strength maximize, surface roughness minimize, and print time minimize. Now let's go to setup. So if we go to the setup, similarly to the previous case, so we have like the low and the lower and upper value. Those are taken from the experiment, and the target, if we are maximizing, so is the upper bound, and for the other two that we want to minimize is the lower bound. However, here we can specify a type, an importance and value, and this will be taken into account when it gets, one solution that prioritize all of them. So Jonathan, so which of these three would you consider to be the most important?
For us, the most important will be the two related to quality, so strength and roughness.
Okay, so let's put 1 for strength, so it's like the one with maximum priority, and let's put like 0.8 for softness, roughness. We always can come back and make a different combination. So the print time will be, the least, important. So
The half maybe, 0.5.
yeah, so let's take 0.5. So say that this is half of the strength that is the most important. So I will just click OK. For the rest, we don't need to click anything. So we just leave it as default. So I will just click OK. So now Minitab will recommend a solution that, combine the three of them. So these are the results. So now we have, instead of having 3 different solutions, we have 1. And, the recommendation in this case is to use a layer height of 0.3 millimeters, print speed of 40, and infill density of 20%. And we have in the, what is a fit, those are the expected values for the strength. And we also have like a confidence interval because, we know there is a variability in the process. So it's not that you will always get 85 megapascal for strength, but it could be from 84 to 86. That's like the expected range. So now here is good. You have now a unique solution.
And if I see this solution is not coming from my experiments, or is one of my experiments?
No, it's not necessarily one of your experiments. So when we create made the experiment, so Minitab create like a model. So with that model, it finds these results. So the fit value is from the model, but these settings, so we tested. So we can go back to your experiment and see what was the the actual value. But this combination we tested, but Minitab used this model, and is why we have like a fit. So it's like a type of prediction for your response, and then is when it just the the optimizer. But yeah, we can take a look and see what's like the difference, or what would be like this error in the prediction. You just have like 2 experiments, so maybe we need to get a little more experiments. But let's just compare these results with the ones if we do the optimization independently, the ones that I just show you. So when we tell Minitab, okay, maximize the strength by itself, and not looking at the other variables, so we get 86 megapascal. So with this combined solution, you get 85. So I think it's really good. You didn't lose much there. In the surface roughness, it's the same result. However, in the print time, we can see that if you select just print time, so it will take, around 12 minutes to print. And now with this solution, you get 30. So it's, quite, higher. But, it was because we specify that was half of the other in the priority. So if you think that 30 is too high, maybe you can go back to Minitab and specify, for the print time like 70 or 80, and it will, generate a different solution based on that priority. But the ones that you care, like the strength, or you care the most, strength and surface roughness, we got pretty much the same results. So I will recommend you, if you are okay with this, performance. So if they are according to your process, so just try these settings. Maybe you can make a few more prototype before going to full production, and just test that they are going well. Or we can go back to the optimizer and change the priorities, and maybe we can get some different settings. So what do you think?
So the way to go will be now to make a new prototype using this configuration and see if the results really match to the desires that we want for quality and for time. Right?
Yes, yeah, I will recommend you to do that. So before going to full production, let's do a few more prototypes using, you know, these settings, and if they go well, so then you are good
Then we
to
go
go.
for production.
Yes. So, you know, as a summary, so this will be, you know, the proposed settings and the expected results for these, you know, prototypes. So, you know, please go back to the lab test, you know, if they work well, or if you want to, you know, get another solution so we can change the priorities, you know, another settings. But this will be, you know, the recommendation considering the priorities. Or if you say, okay, no, I just want to look at the strength, so just go to the table when, you know, when we have these three tables and select strength, time, or roughness.
Okay, thank you very much. I think this will help us a lot to improve our process by doing prototyping on a specific value, that we are not looking for values in areas where probably we don't have good results. So this is going to help us a lot.
So, you know, any question that you may have, so please let us know.
Thank you.
You're welcome.